Hey guys, it's been a while since I've done the last video, so I'm doing a test piece, how to do a sprockets. So I have a part that has a amount of sprockets. All these sprockets, program for that, it's pretty extensive. As you see, so you pretty much have to kind of figure it out each tooth, and then at the end, what I do is, let's say if you got 12 sprockets, you just do continue. That's going to be at the end. Let me show you. You do continue, repeat. So let's say if you got 16 sprockets, you do repeat 16 times, and the distance between each sprocket, so you shift it, let's say 1.5 inches. This is going to be done with paper and mill, and pretty much what I do is the bottom of this sprocket, it's going to be three quarters, so it's 1.5 inches, and I start 20,000 from a Z. The approach I've adjusted to minus 130,000. That's my perfect clearance. It goes to 130 on a Z. So as you see, these are rotations. So I go from one side of the sprocket, which is at, let's say, 341 degrees, to, let's say it goes in, it starts on 341 degrees, okay, 0. It goes to depth 130,000. It's going to be with same degrees. Then still at 130,000 depth, it rotates to 344 degrees, which is a 90-degree rotation. And with those 344 degrees, it comes out outside to minus 20,000, and then it goes up and it jumps to another one. So I'm gonna do a run. So I used an aluminum piece. I prepared same thing, 60,000 width, 30,000 per side. Okay. Sorry for the bad sound. So this is a 3/8 30-degree paper and mill with a ball. If you can get a tool that's perfect for your teeth, you literally can just use a line center to go in, out, and rotate. If you guys are interested, I can maybe do a little bit more extensive video. Right now it's at 130,000 from a Z. Okay, pushing, no angle change. Now I can also set it. And 130, shift. They shift first side at 1.4 degrees to get the sharp corner. that last tooth, it just did. So this is a little bit tricky one. Okay, let me explain. So the way you calculate the last one, and I'll show you. So normally, as you see, we have a program. You have a tool. So I call it 380T for taper. I made an adjustment to that. That originally was minus 190, and it was coming out way too far, and I don't want it to cut into the material. So like you see, everything pretty much, you know, the numbers. It goes plus. So let's say originally I started with 3 degrees, then 3 degrees, 23 degrees, 43, 63 every 20, right? So then originally this was 183, subtracted that 1.4 thousand on the top two, and then I've added 1.4 thousand to that 183, which I came out with 184.4, right? But because the last tooth, you do only one side. What's crazy, and I had an issue with that, was, as you see, it jumps from 344 to 1.6, and you can't just rotate it. I'll show you like what I did to come out with that 324.8. Okay, so when you use a line center and you have a tooth, there's a difference between angle from here to here and from here to here. That angle you have to subtract from 360, okay? And that angle you put over here, okay? And how I got that angle, I subtracted the starting number from previous number, so 341.6 from 324.4, and that number I subtracted from 360. I got that 342.8. So when they came in, it adjusted that angle from this angle to this angle instead of between this one and this one. It's a little crazy. I don't know why I did it, but I had a problem with that last tooth, and finally that's what do. So that's how you do Sprocket. Well, like I said, the simplest way is if you can get like all the dimensions out of Sprocket, grind it, you know, do a custom grind. All you have to do with the line center, just go in, out, rotate, in, out, rotate. So, you know, if you got 20 teeth divided by 360 divided by 20, make that many units, and pretty much just go in and out, and that'll be the simplest way to do jobs like that. And like I said, and you can pretty much run them in the room. Alright guys, thank you for watching. Make another video when something different comes out. If you guys need any information, whatever, you can always ask. I'll try to make a video about whatever you guys need. Keep machining on, and see you guys later. Hey guys, so previously, about an hour ago, I made a video how to cut Sprocket. So this is the part. You have 15 sections. Okay, each section is 1.5 in So what I did was I took my drill over here. I brought the tool right to the center of the Sprocket. Okay, and I set that center of the Sprocket as my drill. So right now I'm just using a regular 360 head mill. I set it as a line center, and this head mill only goes in and out, okay, every 20 degrees. Does not rotate, does not cut teeth, but just trying to rough it out. So once I get in there with the paper head mill, it has less material to remove, and hopefully it's gonna last a little bit longer. So close the door. Okay, so we have a little bit more, a little bit better I'll do it. Okay, so as you see, my C degrees are 3, 23, 43, and so on, 63. So every 20 degrees, right? Each section when it rotates. The reason I didn't start with the 0 is because I knew I'm gonna have to rotate back and forth. It depends on an end mill. Previously I had a different angle, so I actually had to rotate as much as close to 10 degrees per side. With the current setup, my rotation is 1.4. I'm going to mention that later when I see another video. So from 3, I can rotate the part to 1.6 degree and then switch it to 1.6 to 4.4, which gives me 1.4 degree swing. So as a line center, like I said, I'm using it's a 0.1875 end mill. These really don't matter. This is a line center that's only doing one pass. Obviously, speed and feed you have to adjust to whatever you feel comfortable with, and it depends on the material and how much material move and such. So around 1 inch and 600. This is a little bit below. This is like 1 inch and 595, I think. It's the maximum I can go in. Let me see that. So because when you have a tooth, it's like this. It's got that radius. That end mill gets over here. If I would go any lower, it would start cutting into the radius, and which I don't want to do. So this is how far I'm going, and like I said, the center of the end mill is right at the center of the teeth. So when your part goes like this, it's straight, then it goes down. Okay, and then you have that tooth. This is a 0. Okay, so what I did was I set the approach myself to start 125,000 before 0, which kind of roughly gives me about 30,000 clearance. The reason for that is if you don't adjust this, the end mill will travel to, let's say, 160, and then it tries to retract way back. So if it retracts too far, it will cut into that material over here, which I don't want. Okay, so I have a very little clearance, and so I kind of calculated how far I can go. So I can go 30,000, and then it goes about 30,000 past the sprocket, and even though that it's at -20, it will still hold on to the approach. So it starts at 125, it goes to 160, and even if it retracts to 120, the material's been removed, so it can go back up, rotates, and go down. How far up it's gonna go, it depends what you have over here. If, let's say, your part is 2 inches and you set this OD to 10 inches, it will go up to 10 inches, rotate, and come back down. Okay, so end mill, and let me see. So line center, this is a Z and a C mode. These are your how much material you're removing on A and then R. So this is going to be your height, and this is going to be your Z. I'm not sure. You can press on this one. I don't going to allow me to. And go to question mark, and this is going to show you the plane, and which is the R, and this is the depth is going to be your A. Okay, so the depth we're going to when we're starting, so remember those two. The approach, this is going to be at 20 degrees because whatever you're going to put on the seal over here, it says you see like at 3, 23, 3 inches, 23 inches. So this I don't touch. Okay, your speeds and feeds, and this is pretty much just the through line. So it starts at minus 25. It kind of goes to 20. It keeps going to 160. It keeps going out to 20, and then it shoots up. If there's an issue with the clearance, you can always, if for whatever reason, but the thing is that it will always go up and rotate. So even if you had it out to a 0, okay, it's gonna go up, it's gonna rotate, so it's not gonna remove any more material than you have to. And then you go to the next one. Same repeat, so now we have 43, 63, 83. So we pretty much go all the way to last one. And now we have an end. We do continue. We're gonna repeat 15 times to shift 1.5 inches each time. Okay, and we return to tool change. Now, by any chance, and right now because I'm gonna be leaving home soon. So what I'm gonna do is the next time, once the first piece is gonna be done, I'm gonna shut that end off to make it inactive. So now this is gonna be that line center with that 3/8 paper end mill. It's gonna jump in. So once it cuts all the grooves, it's gonna jump to this one, continue. Sorry for doing it. Let's continue to the sprockets, and over here I'm gonna enable this end, and I'll do continue. Okay, shift 1.5 inches, repeat 15 times. So what it will do, it's gonna do it's gonna rough the part and then do sprockets, and then it's gonna loop again, rough and cut sprockets, rough and cut sprockets. If you just want to rough, like I said, you can enable the end after after this one, and this will only rough. So right now the sprocket units are pretty much off, but once I rough this out, I can disable the roughing, enable just the gear cutting option with that 378 paper, and so it's just it saves time. And the only thing is, like I said, I mean, it's you have to enable a bunch of units. There might be an option to probably, when you do one line center, go and create a repeat end option, and then have it rotate, and then rotate, and let's say do every 20 degrees. So that way, let's say if you need if there's like 18 teeth, repeat 18 teeth, rotate 20 degrees, and you could probably figure it out then to do it on one line. I don't know if you can do that in line center, but I know there's some units that you are capable of doing that. I've done it before, just not sure if this one. This is the first time I've done that particular job. So that's originally how I started doing. I know there's some options, like I said, for different. There are options for different ones, but when it comes to stuff like that, I mean, I think line center it's fairly easy to program. You just have to figure it out. The sprocket. So what you do is you cut one side. Let's say 1 degree. Turn the other side 1 degree. If you don't get that point, then let's say do 1.5 degrees, 1.5 degrees. If you still don't get to the point, then you just continue till it's sharp. Write down whatever you're going to go. Whatever degrees you have to rotate your C on, and I mean that's how I've kind of done it. That's how I figured out how to do that job. if you have a 5-axis, then then you can angle your angle whatever you want, and it'll be much simpler. Or like I said, just have a tool grind it to resemble the shape you're looking for. All you have to do is one pass, pull out, one pass, pull out, and you're good to go. I'll post a picture for reference, like that, explaining it exactly, a little bit clearer. But oh yeah, like I said, I mean, the last line, this one, just subtract this one, which is 341, which is the first one, starting line, from the last one on previous angle, and that will give you the difference degree, which you subtract, like I said, from 360, it will give you that number. This is the only line that that caused me some headache. I don't know why, but I guess the way you calculate these things, they will not rotate past 360. So let's say if you're at let's call it 358, and let's say you're trying to go to gotta check on like 30. Pretty closely during the job. Just want to make sure. Yeah, it won't go from, let's say, 258 to, let's say, 8. You have to rotate back with 348 or whatever the difference is, back to that original first point. All right, guys. I'll post the first video. I'll post this video first, and then the second video I'll try to maybe combine them, and maybe somebody got something out of it. Thank you.